Hello, guys. Welcome to our section. I know that the seats are really comfortable, but please don't fall asleep for the next 25 minutes. My name is Graziano. I know that this is not the easiest to pronounce, but with me is Eric, and this is the way easier, don't you know? We actually come from two different backgrounds. I'm working in Mia platform, and my focus is platform engineering and developer experience, trying to build something that is useful and makes the engineer's life easier. And Eric's came from Chronosphere and is focused on system reliability, and he is especially experienced in the observability of the systems. We met 2 years ago in a conference, and we started to think how we can bring together our worlds, platform engineering and observability. And here we are now to talk to present about platforms powered by the observability superpowers that make engineers able to build systems that are observable by default and not by effort. It works?
Before he goes any farther, the slides are online right now at Schabell.org. So if you feel like you need to take any pictures, you don't have to. You can go get them there.
Okay, let's start with the problem. How many of you see yourself in this picture? How many of you started by observing the system and ends out just by adding complexity? You start to collect a lot of traces, logs, metrics, but you just can't get insight from them. And yes, exactly. I believe each one of us, at least one time in our career, feels like that. And if observing the system by collecting this kind of data is way more difficult than to build the system itself, maybe something is wrong in the way we observe the system, don't you think? So, okay, now it works. So let's start by understanding why we have all this complexity. First, maybe you can start the journey by starting small, just setting up all the tools you need and the processes you need just to have a system that lets you know that something is going wrong. Like, hey, your pods failed yesterday at 4 p.m. Or, hey, your application was not reachable for 20 minutes. But this way you just know that something is not going wrong, it is going wrong, but you don't know actually where is the failure and what is not working. So then you start to want more. You start to evolve the system to get insight on what and why something gets wrong. Sure, knowing that something is going wrong is helpful, but having a system that tells you, hey, the order service went down after 20 concurrent calls to a specific endpoint due to an out-of-memory error is much more easier. It gives you much more insight to debug the system. Then you could think that you have enough data to debug easier your application. But the truth is that in a distributed architecture, the system affected is not just the system that have the internal failures, but also the other services that depends on it could experience some problem. For example, if your order service fails, even if the warehouse service is not affected by any internal errors, could happen something wrong in that, because maybe the order service is down and maybe the warehouse stock is not updated because the service is not running. At the end, probably you start thinking that you can change the mindset where you approach into the observability. Right now, you are working with a wartime observability mindset where you aim to try to identify past issues to solve them. But you could start thinking at something more proactive, where the focus is not to spot past issues, but to prevent them. You want something that said, hey, Your services is reaching a level of request that can handle with the current replicas, so that you can you can schedule all the activities you need to do to prevent this issue. In this way, you are not working to solve problem, you are working to predict and solve this problem before they become failures. But before trying to understand how to solve this complexity with platform engineering, we'll try to understand when this complexity came out for the first time. The reasons are three. The first one is the most obvious one, and are the tools. Each phase needs tools. When you want to get more insight, you need to add more tools. And adding more tools actually means that the cognitive load for your SREs or for your engineers is way more increased. And adding cognitive load makes the overall system more complex. Then the data. When you are adding tools, you also add and you also get more data. And more data collected in terms of traces, logs, and metrics means that you have more dots to link together. And when you have more dots to link together, you have to find a way to make out the most of the data with less. Last, maybe the most overlooked problem, is the interaction, the transparency of the system. You could have the most powerful observability stack out there, but if your engineers struggle to find inside to make them actionable, you are basically wasting your time and resources. So you have to work to make the whole system much more transparent and makes the data actionable for the engineers. But let's start now with the first problem, tooling. Eric, would you like to explain us?
Yes, you can keep the clicker there. I'm going to ask a couple of questions over here before I get the light in my face and I can't see you. So how many SREs here in the audience? Ooh, that's like the most I've had in an audience in a long time. Anybody carrying the beeper right now? Who's a developer? Developer and an SRE? Managers? What are you doing here? All right. Everybody familiar with CNCF? Everybody familiar with their observability projects and stuff like that? So realizing that this is not an all-encompassing thing, we put up here an architecture for an observability stack that's rather comfortable to get started with. At scale, it gets more difficult, but this is very comfortable, right? You can cover logs, metrics, traces, events, anything you want to do in that sense. And try to design it here on this slide in a very, you need to stay away from speaker. Try to design it so that you have the ability to use multiple collectors here at the front end, the ability to do storage at the back end, and the ability to do some visualizations. Anybody familiar with the Perseus project? Just one. Ooh, you might want to go check that out. It is very young, but it's a data visualization based on the PromQL language. Next click. How many people here use Prometheus? About half. Okay, for those that don't, basically what you're looking at is the ability to collect metrics. This is a very specific and focused signal. It includes also storage out of the box just in memory. So generally what people tend to do is add a time series database behind it, not really diagrammed out here. It's all encompassing, and it includes the ability to instrument your code, the ability to auto instrument your code. One of the great deviations from most of the products or projects that you will use is this is somebody that goes out and scrapes targets. You don't push, so you don't have to put stuff in your code to push. All you're doing is exposing an endpoint with the metrics when you instrument. And Prometheus will come get it. You'll target various systems. You also notice it uses service discovery. This is something you absolutely need in the cloud native space because you're getting brand new targets all the time as it scales up and down. It's able to self-detect and continue to scrape those. And then it includes some fun stuff on the back end, like alert managers. So when you set rules and thresholds and things go through those thresholds, it's nice to see somebody's beeper go off. Unless you're one of the SREs that put his hand up, then you're probably not really enjoying that part. The dashboard, the visualization I put there is not externalized. This is what I'm referring to as the native stuff that's built in to the Prometheus console. Rather fundamental. It's not really great. They've started expanding with the new version 3 and included something called PromLens that used to be an apart open source project. It was sort of developed as an educational tool. What's really nice is PromQL is not easy. Is anybody here really good at it? See, nobody dares to say yes, right? We have special channels internally called Prom Queen, and it's like, help, right? Help me with this prom, right? It's really, really, really hard to do a really good Prometheus queries. It's not that it's not designed well. It's really well designed. It's just a very hard domain, right, to get what you want out of it. You'll notice these QR codes and hard to read links at the bottom, but there's workshops that we put together to let you do all this stuff from the ground up and learn it as much as you can, right? There's about 8 or 9 labs in this one. It's a pretty complete one. Next. Then we move to one of the labs here that actually exposes it to the developer aspect, because a lot of the observability stuff is fun and games for people in the should stand in front of you. It's fun and games to do the observability stuff as an ops or an SRE or somebody who's looking at dashboards and dealing with collecting metrics. But what about the developers, right? You're in DevOps and you're supposed to learn how to do this kind of stuff. You're instrumenting code and you're being forced to go look at some of these dashboards. This is an actual Java example where you instrument a Java class with the 4 basic metric types. It's pretty good. Next. OTel. Anybody here using OTel, OpenTelemetry? We just had a whole talk on it by the CoreLogic guys. Are you finding that extremely easy to use? Yeah, extremely easy. I only see 1 thumbs up. All right. There's a whole lot of people out here that are selling talks all over these events you go to about how OpenTelemetry is how you should be instrumenting everything. When you get into reality and get out there in your organizations, is there anybody here that's all in on OpenTelemetry and nothing else? Yeah, exactly. Right. Most things are quite complex. This is one of the things you'll run into. It's one of the things you might want to go to. You should be able to understand how to use this together with other things. It's not the only thing. They put together the OTel collector and the OTLP, the actual protocol. This is a good thing, trying to get standardized on telemetry data protocols. The problem is it's run really fast and really hard, and you have to keep a close eye on it because there's a lot happening in this ecosystem. A lot of people donate stuff to this ecosystem, and it is collected but not well maintained, unfortunately, or stale or whatever's in there. So you will see a lot of frustration when you go out there and look around this. I'd like to hope it's getting better and better, but just be aware of that. It's not the only thing. Works roughly the same way. We have for example, a Java application out there. You have the ability to use SDKs to write your own connectors, collectors, and all that kind of stuff around OpenTelemetry and OTLP. Generally speaking, using like auto instrumentation or even specific instrumentation inside your application, you're ejecting your telemetry data out of there. Metrics, logs, traces are all available. Their core fundamental thing they started with was traces. So they're really, really good at that. Notice that the collector agent has no backend. So whereas Prometheus provides the complete story, this does not. So be really aware of that. Not everybody's really up on that until they get started. And then they're like, whoops, what now? Next. So you do need a backend. That's important. Jaeger is a really easy one. That's an opinionated visualization tool and storage for traces, right? Saves you from having to write all that stuff. There's lots of vendors out there with platforms and stuff that'll let you visualize that stuff. If you look at the Perseys in our thing, they're not that far along with traces yet. They have not yet done the OTLP integration, but of course it's in the planning. Next. FluentBit. Anybody doing anything with FluentBit? This workshop is well worth your time. As you can see, this is a completely simple and easy tool to understand. 5 phases you go through as you ingest data. Originally, traditionally, it started with FluentD. That was an APM logs collector, basically turning English language logs into JSON, right? Machine readable, machine parsable, because I don't know about you guys, I spent a long time being a Java developer back in the day. Used to spend a lot of time at the coffee machine while my code was compiling, and we'd be talking about what kind of messages we're putting in our exception and stack traces and stuff. Because some human's supposed to read that, right? Not really how that works. This is a lighter version, less resource intensive, meant for the cloud native environments. It's really hard to put an APM monolithic kind of tooling like FluentD out there into the Kubernetes space. So they developed this. It's super lightweight, super fast, super performant. You can have lots and lots of these out there collecting at the edge. So right up front. Also gives you the ability to The parser turns it into a JSON format. The filter gives you a language of your choice, from regular expressions to Lua to all kinds of stuff, to write your own aggregations, to drop stuff, to change stuff, to add stuff, all that kind of things you'd want to do with different labels in there. Different buffering strategies, be default out of the box, just in memory. And then you can route it anywhere you want. So basically the whole catchphrase here is anything in, anything out, right? They expose metrics endpoints so turning whatever you're ingesting into, and there's a whole bunch of plugins at the front end. There's a whole bunch of plugins at the back end. You can send it to proprietary backends. You can send it to Elastic. You can send it to all kinds of things. So it's been around for a while. Really fun seven-part thing. And the very last one in there, go to the next one, includes taking a telemetry pipeline that then converts it into an OTel envelope and then forwards it to an OTel collector that then outputs it into the file system as if it's another destination somewhere. You do all this in one lab. I'm also doing this Sunday I'm going to try to do it live on stage, Sunday at Regex, if you happen to be a Cloud Data Regex. You don't need to do that because you can do it yourself. I guarantee it works. You can do it with a source build or in a container. It doesn't matter to me. So check out the workshop. It's really cool. What's next? Too bad that this is not very well visualized here based on the projector we have, but this is what you will build from scratch if you do the Percy's workshop that I put together for you. I try to keep this thing up to date. It's only at 0.50. So that's a very young project. They just reached sandbox status. They're going to have anybody here going to KubeCon? So if you go to KubeCon, they're going to have their first ever booth at the Project Pavilion. So stop by and check out what they're doing. Really nice guys. Next. And so this is bringing us to how you're empowering everybody with all these different tools you're putting together, all these different platforms you're putting together. It all sounds rather disjointed right now. So to the next slide, how do we make everybody a hero? So really quickly, before I pass this off into the platform engineering expert next to me, this is not the only way to deploy this kind of stuff. You have to make a choice to give you some kind of architecture to look at. So basically we talked to everything. It's a little hard to see everything inside of Kubernetes. There's different ways, for example, to deploy Fluent that can be right next to each one of these applications as a Helm chart. It's in, watching every single one of these things. You can do OpenTelemetry the same way. You can have them working together, as you see in that one lab I talked about. Prometheus can be collecting stuff from your applications. It can also be completely externalized from your Kubernetes cluster somewhere else and collecting remotely like that. So there's lots of different ways to do that. We included Jaeger and Percy. With that, I'll pass it back to my paved path story.
Okay. The first part are tooling, and to solve the complex of the tooling, we can put it all together into the platform. And the platform is supposed to provide two things, basically, standards and abstraction. How it can provide standards and abstraction? It can do it by provide to developers, to engineers, favored path or golden path in the literature. That's allow you to put everything together into the architecture you see there, and that Eric explained. But which is the first thing that provide abstraction? This thing is the pivot path that can happen in the form of blueprints, for example, which are templates that provide to the developer all the stuff they need to start their application with observability as a first-class citizen of the platform. And they can, for example, start with the blueprint that have integrated inside all the hotel instrumentation, for example. In this way, the developers, the engineers can develop their application without even knowing how the stack is built, how these different tools works together. Then the second point was about connecting the dots. The second point was about managing all the data you have. The platform is the way to centralize all the data you had and work with the telemetry pipeline. This way, you have the possibility to manage all this data in an aggregated way. You have the possibility to make a correlation between data coming from different services In this way, you can work not just by collecting logs, traces, and metrics from the hundreds of services you have deployed on your cluster, but you can develop them, you can collect them thinking at flows, which they are user journeys, which they are, for example, in critical business processes. And you can provide these flows in an aggregated way so that using the platform, the observability effort becomes not just a backend tool for debugging, but flow-driven activities that give insight to you about your application in your context. Last, there was the transparency, the data visualization path. And you can see on the screen, not properly, but you can see it, an image that explains how the platform is consumed by the different personas inside the company. You start with the platform engineering team, which often take into the SREs, and they are interested in, for example, runtime insights. Then you have other stakeholders, like the internal stakeholders, those who have the decision and who have who overlook the entire software delivery lifecycle, and they probably look to manage the cost of the infrastructure. Then you have the product teams. They are interested not much about CPU usage, but more about insight on the performance of what they are building. And then, of course, the end customers that are interested in the reliability of the system. The point here is that you have to build your flows, build your dashboard, everything you want to build in a way that is actionable and easy to be discoverable by the user, thinking at their needs. In this way, the observability stuff is just something that you collect, hoping that one day it can be useful, but it becomes a shared languages inside organizations so that it can drive decision and action. That was the last part of the presentation. So if you have any kind of question, me and Eric are here to answer. And if you miss the other QR codes, you can scan this one and get all the workshop presented by Eric in one time.